Oh, sorry, Annette, you're muted. I can see you talking.
Repeat again. Hello. No matter how many times I do Zoom, I'm still muted. Hello, my name is Janet Valdez, and bonjour, good morning, everybody. Hola, and I will be moderating this town hall today. But first, I would like to begin by acknowledging the indigenous peoples of all the lands that we are on today. While we meet today on a virtual platform, I would like to take a moment to acknowledge that I am joining you from the traditional, ancestral, and unceded territory of the Musqueam, Tsleil-Waututh, and Squamish First Nations. As a visitor on this land, which I call home, coming from Cusco, Peru, I strive to deepen my own understanding of the local indigenous communities and commit to reframing my responsibilities to land and community. Today, we have an exceptional panel of patients and experts to share with us their knowledge about long COVID or post-acute COVID sequelae. Thank you, panelists, for being so generous and giving us your time, your hopes, and your knowledge with the public. I feel, and many of you in the audience might agree with me, this is an important topic that needs urgent attention from all levels, from awareness, advocacy, science, clinic, and policies. So welcome, bienvenidos, and the panel, it's gonna be in English. However, if you have questions in French, please don't hesitate. We have French speakers and Francophone people here as a panelist, so they can answer questions in French. And si tienes alguna pregunta en español, igual, por favor, haz tus preguntas y vamos a tratar de traducirlas en español, en inglés. With this, I would like to welcome our panelists, and I will start first with Mrs. Carrie Ann, and she's a patient and advocate. I'm not gonna tell you the extensive biography of all our panelists. It's impressive, but we have in the chat already a PDF you can read on your own terms. But Carrie, I'm so glad you're here. Thank you so much for your time. Please go ahead and start presenting.
Thank you for being here. Merci d'être là aujourd'hui. I contracted COVID-19 in December of 2020, before vaccines were available. My initial infection was not a walk in the park, but I wasn't hospitalized, and I expected to fully recover. Well, 18 months later, here I am, still sick, chronically ill, and disabled. I live with long COVID, but that is not all. My acute infection also triggered other illnesses and conditions. I now have myalgic encephalomyelitis, or ME, known to many by its previously stigmatizing name of chronic fatigue syndrome. ME is a chronic, complex, multi-system illness with no treatments and no cure at this time. COVID-19 also triggered a form of dysautonomia called postural orthostatic tachycardia syndrome, or POTS, and it also damaged my heart. When I fell ill in December of 2020, I had vaguely heard about persisting symptoms after an acute infection. But long COVID, this god-awful illness that can cause over 200 symptoms, that leaves me permanently disabled? Nope, I hadn't heard of that. And sadly, many Canadians still haven't heard about it. And yet advocates have been warning our government about it since the early days of the pandemic. Myalgic encephalomyelitis, or ME advocates, predicted long COVID and were the first ones on the advocacy scene. Sabrina Poirier, a prominent Canadian ME advocate, started reaching out to Canadian governments as early as February 2020, This tweet is from April 2020. These advocates were advising COVID-19 patients to stop, rest, pace, and warning governments of the mass disabling event ahead. They knew other viruses trigger post-infectious illnesses like ME. First waivers, who got long COVID early in the pandemic, also rang alarm bells, publishing the first patient-led study in May of 2020. We knew that after the 2002 outbreak of SARS in Canada, patients reported feeling unfit to work for up to 3 years after infection. There was every indication that COVID-19 would be no different. And research now confirms that COVID, yes, does cause post-acute infection syndromes. And yet, from our government, even today, crickets. And this despite that we now know that long COVID is in fact a mass disabling event. Long COVID affects anyone of any age, background, level of health, or vaccination status, even children. No one is safe. 30 to 40% of people who were infected but not hospitalized still report symptoms beyond 12 weeks. And many of these Canadians are being driven out of the workforce, with women bearing the brunt of it. In fact, 3 out of 4 people with long COVID are women such as me, between 30 and 60 years of age. Most of us are without adequate disability supports, such as disability insurance or access to the Canadian Pension Plan disability benefits. And now, recent research is showing that at least half of people living with long COVID meet the diagnostic criteria for ME and POTS, illnesses which cause lifelong disability. There is a tsunami of disability coming to Canada as a result of long COVID. For me, long COVID, ME, and POTS have caused me to lose my life without dying. All areas of my life are affected. Just accomplishing the essential activities of daily living and parenting my small child uses all my limited energy. I am housebound. I'm so exhausted, I can only shower once a week usually. My beloved career, which I worked so hard to build, is gone, and I can't work. Long COVID has changed how I parent, and it was the final nail in the coffin for my marriage, and we separated. I used to hike mountains, and now I am housebound, and I spend my days in bed. I was a career woman, a world traveler, a busy mom, of wind in my sails and a life full of promise. I'm now forced to forge a new identity as a disabled woman and advocate. Long COVID has been truly devastating. It has taken so much from me, and it has left me with so many symptoms. Long COVID has over 200 of them, which fluctuate over time and worsen with relapses. People with long COVID and post-infectious illness, we are languishing in our beds. We're without income, without disability support. We're being gaslit by our healthcare providers, many of whom chalk up our illness to anxiety or psychosomatic causes. We need adapted, accessible, evidence-based care and biomedical treatments. Our healthcare providers lack knowledge and training on post-infectious illness, and many, despite well intentions, are still causing significant harm to patients. The few specialists and services that exist across the country are now at capacity and exceeding it. Even the best in the field are only able to help patients learn to pace, manage key symptoms, and their comorbidities. And let's be clear, that's not enough, but at least it's a start. We need to partner with and learn from the myalgic encephalomyelitis community. At least half of people with long COVID will develop ME, a chronic, complex, multi-system illness with no treatments and no cure at this time. ME has the lowest quality of life among chronic illnesses and one of the highest prevalences. You know, sometimes I ask myself, would long COVID even exist right now if medicine had paid attention to ME? ME research has been underfunded in Canada, and patients' needs have been ignored for decades. As researchers such as Professor Iwasaki, who will speak after me, begin to understand and appreciate ME's role in long COVID, these alarming estimates may unfortunately grow. So now is the time to work together, to build allyship, and bring everyone along for the fight of their lives. The fight for biomedical research, for treatments, and eventually, a cure. I think it's time to recognize what's in front of us. Why are we so hesitant to move forward and take action? Long COVID is nothing short than an ignored public health crisis, a crisis which is ruining the lives of those affected by it, fueling labor shortages, increasing gender equality, straining existing health resources, and highlighting the unmet needs of more than 500,000 Canadians who are living with ME and other post-infectious illnesses even before this pandemic began. So now is the time for Canadian governments to take their heads out of the sand. Now is the time for them to use their powers to protect the people they serve. So many lives hang in the balance, including mine. So please, stand with me today to demand that our decision makers invest in biomedical research and clinical trials to better understand the underlying mechanism of post-infectious illness and to find a diagnostic biomarker and treatments for long COVID and ME, so that people like myself may one day get back to our activities of daily living, our careers, our relationships, so we may get out of our beds and back to the lives that we so desperately miss. Let's also ask those in charge to improve clinical care through medical education and further investments. Post-infectious illness should be common knowledge, and knowledgeable and safe clinical care should be available to all. There will be an increase in the number of Canadians living with disabilities due to long COVID. It is necessary for our governments to strengthen disability supports, which are sorely inadequate. This could be achieved by increasing the number of weeks of employment insurance benefits, in creating a better access to the Canadian and Quebec pension plan disability benefits, and implementing a universal basic income. In conclusion, I want to thank you for being here with me today and inviting me to speak. We are often asked as patients to attend a variety of events and to share our stories, our experiences, even our grief and trauma. And while we're happy to do that, especially if it affects change for us and for others, it can be incredibly frustrating to do it over and over again when nothing changes. So I hope that those listening today will understand how much of my precious energy I've put into my presentation. How many of us are waiting, languishing in our beds, suffering financially, being gaslit, and losing all that is near and dear to us. So please, take my words and go on to do better. Demand and create action. Be the change that we need. Please feel free to reach out to me by email or Twitter if you'd like to continue the conversation. And if you're in Quebec and living with long COVID, please join the bilingual, science-driven support group I co-founded. Thank you.
Amazing. Thank you so much, Gary, for sharing with us your hopes, your passion. And I am asking the audience to really listen, active listening of people like Carrie that's putting a lot to share with us what is her life. Thank you. To continue with the presentation after this, our patient and advocate presentation, I would like now to introduce fantastic scientists, and I'm honored to introduce Dr. Akiko Iwasaki. She is a mentor. She is a fascinating scientist working to address issues like the ones that Carrie Ann had shared now. So Akiko, please, I will ask you to turn on your camera and start sharing your presentation. Welcome, Akiko. Bienvenida. Bienvenue.
Thank you very much. And I also want to second Janet in her comments about how grateful I am for Carrie Ann for sharing her experience and such a passionately, and I'm still trying to emotionally recover from that. In fact, I began my quest for trying to understand long COVID because of people like Carrie Ann who reached out to me, and I get many emails every day from people suffering from long COVID, and it is really a strong driver for me to be committed to try to understand this disease from a basic scientist standpoint. So I'm going to share my screen. So today I'd like to talk about immunology of long COVID and really listening and learning from patients. We are making the patients a central and equal partner in investigating this terrible disease. So a lot has been talked about with respect to how long COVID exhausts the body. It involves pretty much every organ system that one can imagine. But common symptoms are, include fatigue and post-exertional malaise and POTS and other issues that you've just heard from Carrie Ann about. Clearly, the brain is heavily impacted, as well as the lung and circulatory system and the immune system. Long COVID requires significant investment in research, treatment, and just characterization, care, social and financial support. Every arm of the government needs to be mobilized to really deal with this urgent and debilitating health issue now. As already expressed by Carrie Ann, what we are finding is that there are many unexplained post-acute infection syndromes that occur after encounter with many distinct pathogens. This is a recent review that I was fortunate to write with Jan Chotka, who himself is an ME patient. And here enlisted on the left panel is the viral pathogens that are known to cause these post-acute infection syndrome that also could lead to ME. And the list is very long. Of course, SARS-CoV-2 joins this list now. Also, non-viral pathogens, such as bacterial and parasitic pathogens, have also been associated with post-acute infection syndrome. That's hasn't been really examined and explained in great detail in order for us to understand the root cause of these diseases. If we learn from the experience of the Epstein-Barr virus infection, this graph on the top illustrates the percentage of participants who have a variety of symptoms that are related to long COVID after the Epstein-Barr virus infection. And you can see that these are multiple different studies that are indicated in different colors that if you cumulatively look at this information, you see that large number of people start off with multiple of these symptoms and then eventually come down. But unfortunately, it doesn't reach zero. So even 24 months post mononucleosis, about 4% of the participants are still feeling very ill. And these people meet the definition of the chronic fatigue syndrome. SARS-CoV-2 similarly will start off with a percentage of people with at least one of 12 common symptoms. And this number percentage declines, but does not reach zero. And if you look at this graph on the right, you can see that the self-reported long COVID symptom, as well as those with activity limitations, so these are very severe cases, after 160 days, you still see this sort of plateau of these percentages, indicating that we are going to be dealing with a chronic disabling event in many of these people who fail to recover from these types of symptoms. Long COVID, one of the issues with long COVID is that the clinical case definitions are not universal. There are definitions provided by the WHO, the CDC, the NICE, which differ slightly, but essentially they are all describing this post-infection syndrome that lasts for 4 or more weeks or 12 or more weeks, over at least 2 months. And so, that is probably explaining in part why the prevalence of COVID, long COVID, differ between different studies. And of course, different subgroups of people might have different propensity of developing these long COVID syndrome. So if you look at the populations who are had severe COVID, who were hospitalized, potentially even in the ICU, these are the people who tend to develop, at least half of them, if not more, develop long-term consequences. And that is, we know that the risk factor for developing severe COVID is older and male population, whereas the asymptomatic or mild COVID could also lead to long COVID. And that is more predominant in women in age groups 20 to 60 years. And the underlying pathogenesis that lead to long COVID from these two groups of population may be different. Right now, we don't know what the root cause of long COVID is, but we hypothesize that there are at least 4 or 5 separate pathogenesis that can lead to long COVID, including the viral reservoir, which is the virus that's hiding somewhere in the tissue that replicates or that have remnants, such as the fragments of RNA or proteins from the virus that cause chronic inflammation. And autoimmunity is another possibility where people with COVID can then develop autoreactive antibodies and T cells that target different tissues, and that could cause long-term symptoms. Another possibility is the dysbiosis of microbiome. So the bacteria that live in the gut changes their composition and become pathogenic. In other cases, it may be the virus, the endogenous viruses that we live with that become reactivated, and that can cause also some significant inflammation. Tissue damage that's unrepaired or unable to be repaired can also lead to chronic symptoms as well as fibrosis, which may be happening in the severe COVID patients that are discharged from the hospital. In any case, these are not mutually exclusive possibilities. Maybe some people have 3 of the 4, others have only 1 cause. But understanding these causes are important because that is the only clear path to designing randomized clinical trials that can target each of these causes because they're very different. And as already discussed by Kariana, there are over 200 symptoms that's been reported for long COVID. Many of the it basically involves every organ system we can imagine. The symptoms, the common ones are a fatigue and a lot of neurological impact, such as memory deficit and loss of concentration. Sleep difficulty is another one that's very common, as well as many other organ involvement, such as the endocrine defect, cardiovascular, pulmonary, musculoskeletal, GI tract, and many others. Some people have one of these symptoms while others have dozens. About 25% of the long haulers are unable to return to work, which poses significant financial as well as emotional difficulties dealing with this disease. When we break down these different hypotheses that I just described to you, there are several papers that are now demonstrating viral reservoir or viral pathogen-associated molecular patterns, such as RNA, that is found in different parts of the body. And many of these reports actually point towards the intestinal epithelia as one of the places in which such reservoir or antigen can be found. There's also a recent paper in Cell that demonstrated that EBV reactivation at the time of diagnosis of COVID is one of the 4 predictive factors for development of long COVID. The same paper also demonstrated that the autoantibody presence at the time of diagnosis is another factor that is predictive of long COVID development. There are also papers demonstrating autoantibodies against G protein coupled receptors. These are the receptors that's expressed by a variety of cells that control physiology. So autoantibodies could make dysfunction in various different tissues, such as neurons and heart and other places. And I'm going to show you a few data from our own study where we developed a mouse model of long COVID in which the respiratory tract only infection can impact the central nervous system in a chronic manner. And this paper is interesting, where they trained dogs to detect SARS-CoV-2 infection, and they were trained with a supernatant, inactivated supernatant from SARS-CoV-2 infected cells. So some form of volatile compound that is being released by the infected cell is being detected by these dogs. And these dogs were able to identify 50%, about 51% of the long haulers and 0% of the control group, suggesting that about 50% of the long hauler may have a signature of a viral infection, SARS-CoV-2 infection, that may be distinguished by these dogs. So again, there are lots of different papers showing possibility of these distinct hypotheses. This study, for instance, showed that there is elevated antiviral cytokines, such as interferons, that are remaining in the long COVID patients, whereas those who recover in blue, they ultimately reduce the level of these interferons. In fact, interferon beta was one of the most predictive top feature that associated with long COVID. So this again suggests that there is a source of something triggering antiviral immune response, and that could be a viral reservoir, or it could be some sort of autoantibodies that trigger innate immune responses in a similar manner. Another study demonstrated autoantibodies to various G protein coupled receptors I mentioned before, and these types of antibodies could mediate a variety of symptoms depending on where and what cell types they target. Neurological and cardiovascular targets may be one of the target of these autoantibodies against these tissues may be driving some of the symptoms. But right now there is lots of association, but no causality yet. This study that I already talked about, where that was published in Cell recently, demonstrated 4 long COVID anticipating risk factors at the time of initial COVID diagnosis. I already talked about the Epstein-Barr virus viremia and autoantibodies, but SARS-CoV-2 RNA-emia, which means the RNA from the SARS-CoV-2 virus that's found in the blood, as well as type 2 diabetes being the four predictive risk factors for long COVID development. So this is telling us something about the susceptibility and predisposing factors that may be driving long COVID. This study also demonstrated that the circadian rhythm dysregulation is associated with neurological long COVID, as well as cortisol levels being reduced in those with respiratory symptoms. So there are there may be other sort of physiological factors that are being impacted by the SARS-CoV-2 that may be driving these diseases. So the low cortisol levels also have been seen in ME, and that's been one of the features that are common between the long COVID and ME. And so so what is cortisol? Well, cortisol is a hormone, an essential hormone that's released by the adrenal cortex. And there is a very intricate regulation between the hypothalamus and the pituitary and the adrenal gland that maintains the proper level of cortisol. If you have low cortisol, there is sort of altered stress response, and your ability to properly function will be diminished as a result. And so this led to a clinical trial that was conducted in 1998 by my former mentor, Steve Strauss. And this study enrolled people with chronic fatigue syndrome and gave patients either placebo or hydrocortisone, and they just looked at the differences and whether their symptoms improve. So this study found that although hydrocortisone treatment was associated with some improvement in the symptom of chronic fatigue syndrome, the degree of adrenal suppression precludes its preclinical use, which means that the more you give the cortisol, the less ability of the endogenous cortisol to be produced by the adrenal cortex. And so this kind of long-term treatment with hydrocortisone was not a viable option, which means we need to find other ways of treating this kind of disease. Again, we need to get at the root cause as well as how we can treat the symptoms properly. And just to introduce some of our own work, this is a collaboration done with Professor Michelle Monge's lab at Stanford, where we collaborated to examine the impact of mild respiratory-only SARS-CoV-2 infection on the CNS. What we did in this study is to examine the third possibility listed here of a distal inflammation in the lung somehow impacting the CNS. And the other possibility of neurocognitive dysfunction in long COVID is the direct infection of the cells in the brain or the autoimmunity, as I discussed earlier. But in this study, we're really focusing on the third possibility. And we were able to do this because we developed a mouse model in which we can control the infection in different organs. So by introducing the human ACE2, which is the receptor for the virus, only into the lung by using an intratracheal administration of AAV, encoding this viral receptor, and we can come in about 2 weeks later with SARS-CoV-2 intranasally. And we can actually detect viral replication only in the lung, but not in the brain, as shown here. And this lung, you can see some of these viral antigens being detected. This detection of the virus is pretty much down by 7 days post-infection, meaning that there's an acute but just a short-term replication of the virus in the lung. And as far as we can see, there is no more virus after 7 days. There's also no weight loss at all with this very mild form of infection. And yet what we found is that there is an elevated cytokine both in the serum as well as in the cerebrospinal fluid at 7 days post-infection and 7 weeks post-infection. So interestingly, these levels never come down to background. And in fact, there are some cytokines and chemokines that remain high even in the CSF. And very strikingly, we see reactive microglia that are in the white matter of this animal, even 7 weeks post-infection, shown here. So this mild form of a respiratory-only infection somehow led to the sort of long-term impact within the CNS by a reactive microglia measurement. And a similar type of reactive microglia increases were seen in autopsy of patients who were SARS-CoV-2 positive at the time of death. Some people without COVID symptoms, they died of other causes. And then the mild COVID patient, you can see again, the white matter, specifically you see number of reactive microglia that's increased here. In the mouse model, we also see impaired hippocampal neurogenesis. You can see these purple cells in the mild COVID animals are reduced 7 days and 7 weeks post-infection. And we see elevated levels of this chemokine known as CCL11 or eotaxin 1 that's elevated in both the mice as well as in the human people with long COVID who have reported brain fog have elevated levels of this particular factor in circulation. And in the mouse, again, we see loss of oligodendrocyte, about a third reduction in the oligodendrocyte in the white matter, as well as reduction in myelinated axons. Again, here indicated with 7 weeks post-infection, we still see reduced number of myelinated axon in the white matter. So this animal study indicates that even a mild respiratory-only infection could lead to prolonged changes in the central nervous system, and that autopsies from patients who had COVID also showed similar reactive microglia in the white matter. And the direct infection of CNS is not required to induce significant CNS pathology. So what are we doing to try to understand this disease better? Well, we're using animal models, such as I just mentioned, to see what preventative measures and what therapeutic measures might work to alleviate these kind of CNS symptoms, CNS impact. As well as we are studying multiple cohorts of patients that are indicated here. For instance, we have a wonderful collaboration with Dr. David Petrino at Mount Sinai, where we are collaborating to look at the cross-sectional immune profiles of long COVID patients. We also have a study with Dr. Harlan Krumholtz here at Yale, where we are looking at the longitudinal vaccine response in long COVID patients and seeing what changes in their symptom correlate with what changes in the immune phenotype. We also have a Yale Listen study that we are currently recruiting patients, at least in the United States, where we are looking at both symptoms, medical records, as well as immune profiling in order to understand better what features of immune responses are associated with different symptoms. And then finally, we have a long impact cohort. So during the acute phase of the COVID, we we profiled about 250 patients, very, very detailed immune profiling. And now we are following these patients after over 2 years and looking at what features in the initial COVID predicts their development of long COVID, as well as what changes in the immune responses have occurred in the last 2.5 years. So these are some of the studies that we're doing to try to understand long COVID better. And as I mentioned earlier, we are involving patients as equal partners in this endeavor. Not only are they providing input to the study design, as well as obviously their samples and their willingness to share their sort of clinical information, they're also getting results back from us to try to understand what's going on within their own immune system And we have a large network of collaborators here at Yale and elsewhere, where we are collaborating to look at a deep profiling of various aspects of the immune system. And the first study to come out of this would be from the cohort A, but we are doing multiple cohorts, as I just mentioned. So we need a lot of research still in long COVID. We need to understand the prevalence of long COVID globally, which we currently do not. We also don't have any data of the variants of concern leading to long COVID. We need to identify risk factors. We need to identify endotypes. How many types of long COVID are there? And what is driving each of these long COVID? We need biomarkers for diagnosis of long COVID. We need to understand which biomarkers indicate which endotypes. And ultimately, with that knowledge, we can start doing clinical trials for treatment of potential causes that we identify with these biomarkers for pathobiology of long COVID, and ultimately, obviously, much better improvement and therapy for long COVID patients. So I'm going to end here by thanking the numerous people who have not only contributed to the current research, but are currently working together to try to understand long COVID disease better. And there are many cohorts, as I mentioned already, as well as animal models and expertise from various different areas, including patients, that really enables us to move forward in our investigation. So I will stop sharing here.
Thank you so much, Akiko, for this presentation. I know that we have lots of questions, so they are in the chat. In the interest of time, I will be going through, and then at the end, we will be asking some of the questions. But if you have questions for Dr. Iwasaki, please, I ask you to write down in the chat, and we will be answering at the end. With that, thank you, Akiko. Now, really wanna, Anne, are you there? So I wanna introduce a friend. I start talking to her during these presentations with the patients, and it struck me the way her advocacy, how she is working to understand long COVID. Annie Buru, she is a clinician, she's a scientist, and now she's a patient, unfortunately, and she will be sharing with us the challenges of long COVID. Annie, please share your screen and go for it.
Wait just a few seconds. Oops. Sorry, I'm just having a little issue with the sharing.
Annie, we can see it.
Yes, it's just, I have to, having brain fog is an issue, as Carrie said, and need to have my presenter mode to have my notes. So thank you for having me today for talking about challenges of long COVID. As a family physician, having lived experience of long COVID, I will try to enlighten some of the challenges that we have with long COVID and issues. So, of course, we've been seeing long COVID, part of the pandemic equation, but we're pretty much the only one. We really have to, on a population scale in Canada and all over the world, get out of the dichotomy of recovery and death, because the in-between is still the hidden area of the pandemic, and it's probably going to stay with us for a long time. We've been over the definitions of long COVID. Just wanted to show this one from WHO to show how complex it is still. And that's something we have to go over as a complex condition, often described as an umbrella. Here, this is the easy part, the sequelae that we mostly know about. So, for instance, vocal cord sequelae, as you can hear in my voice. I just hope it lasts until the end of the presentation. This is the easy part where clinicians are quite familiar with. But when we get to the post-viral side of long COVID, this is where it gets a bit more complicated. There's been over 200 symptoms described, as was said previously. It's too many of them to put them all on a picture like this, but it's just to give an idea of all symptoms that can turn together and complicate the clinical picture. And if we put everything together, the sequelae, the complication sequelae, and the post-viral issues, and they turn together, you can see that that makes a very complex picture. And also, as Carrie said, after 6 months, many of long haulers have clinical criteria for ME, myalgic encephalomyelitis. Some of you have been asking. And that's something we really have to work on. Just going to do a quick pit stop on what's called post-exertional malaise, which is not very well known. And unfortunately, we really have to pick up the pace on to understand. It's been shown that exertional intolerance, which is a hallmark symptom in ME, is something that's very frequent in long COVID. And it's probably not related in most cases to lung or heart issues, but probably something more peripheral going on with the different hypotheses that Dr. Iwasaki said earlier. It's also been shown that most people with long COVID are worsened by exercise, which is usual treatment or rehab treatment that's prescribed after illness. So that poses the need to really understand what is post-exertional malaise, which is delayed onset or exacerbation of symptoms following a previously tolerated effort, whatever physical, cognitive, or emotional, and it may last for hours, days, weeks, or even longer. There's unfortunately lack of good evidence-based data because it's been neglected for decades. We really, again, have to quick up the pace on that one. And that brings also the necessity to revise the common certainties, such as exercise is always good. As a clinician, always been sort of promoting physical activity and physical fitness. But we have to understand now that in certain situations when post-exertional malaise is present, this is not the answer. The current management of long COVID with post-exertional malaise is derived from the knowledge in ME, which is find the triggers and threshold, learn to pace into this envelope. It's much easier said than done. As an example, it's often described as a cell phone battery. So just try, imagine if you start your morning with 5, 10, 15% of your battery, and you have to make it last for the whole day. This is an image that can help understand what post-exertional malaise is. If you go over your threshold, you'll be set back for quite a long time for sometimes. So after this pit stop, sorry, my breathing is getting a bit harder, but just want to talk about some challenges at every level. We really have to roll up our sleeves because this is probably just the tip of the iceberg. There's challenges for everyone. As was said before, there's so many definitions of long COVID for right now. We don't have universal definition, which makes it hard to compare studies. Data differs from one to another. There are different timelines, and that's an issue that really has to be collectively taken care of so we can have a universal definition. Also, as Dr. Akiko said earlier, we really have to have better description of cohorts under the umbrella. Because right now, most studies are with heterogeneous groups, so it's sometimes hard to gather which group have which issues and to show differences when everyone is mixed up. It's often only separated by hospitalized or non-hospitalized, but we know that it's not the only issues. And having better cohort definitions might also help us to coin the mechanisms and show effect of potential treatments. But one thing that's very important, as I shown earlier with the gears, overlaps must not be forgotten. Some people do have the post-viral part, but also sequelae, which will complicate the clinical picture. There's many challenges for clinicians right now. Most are familiar with many very frequent conditions associated with long COVID, such as PEM that I talked earlier. And that's a very big issue, but it's also true with dysautonomia, AMCAS, ME, all sorts of problems that are very frequent, and we really have to catch up. Routine testing is often normal, which has led to many, it's all in your head talking, which is an issue also. Access to special tests vary, and there's not many very good clinical tools right now to use. And treatments right now are really intended to relieve symptoms until we have better. There's also many challenges for researcher. Just want to point out a recent study that came out, which is very interesting, was designed in 2020. No updated protocol though, and it confirms probably where we don't have to look in sorts of tests because most of them are normal. But in the discussion, it overlooks recent findings and evokes psychosomatic causes because it's the normal testing. And we really have to do better and learn lessons from the past. We must open our mind and really look deeper. So normal routine testing does not equal psychosomatic. It, in most cases, just show we're not looking at the right places. So we have to go into the innovative research, showing, for instance, microclots, showing with very specialized imagery, defects in the lungs, dysautonomia, learn more about that. There's a lot of challenges for patients, as Carrie pointed out earlier. Gaslighting is a very big issue. The lack of awareness with facing like really puzzling symptoms. And we've been through that in the last 18 months. And really, it's really an everyday wondering what's going on. PM being under recognized is so an issue because it can lead to bad rehab situations where instead of becoming better, at least staying stable makes you worse. And there's also a lot of lack of support. Catch my breath and let you read some patients' word that I've gathered. We've talked a bit earlier about the economy. So that's also a very big challenge for economy in the next few years, as so many long haulers are not been able to be back on the workforce and are middle age and big part of this workforce. So this is something that really has to be taken care of. Some more patient words. And one from Carrie on the top there was, I went from thriving to surviving. This one really shows up all the challenges that we have to face right now. There's also a lot of challenges for care. Most structures are weakened from the pandemic situation. Clinicians are exhausted. The amount of sudden disability is huge, and there's a lot to learn, but still, if we try and see the positive side of it, it's a unique occasion for collaboration, and we really have to seize that occasion. Just a quick stop on the lack of awareness. Too many people still ignore the existence of long COVID, and too many people still think that COVID is just a cold for most, which is not. So we still have to educate on the transmission and risks and avoid infection with all the spice possible. Vaccination being one of very big layers, but still it does not prevent all cases. So we really have to prevent as much as we can the infection, understanding that COVID is airborne. So if we look at some key messages, long COVID and other post-infectious illnesses are complex conditions, and our health systems are ill-prepared to face them. Research needs to build on current knowledge of post-viral illnesses and catch up on decades of negligence. We really have to have dynamic knowledge transfer for comprehensive assessment and appropriate care for all Canadians, understanding that everyone's exhausted and it's not easy to navigate through the very big amount of literature going on. So we really have to build newer ways to transfer the knowledge to clinicians on the ground so we can help them better manage long COVID. It's also a unique occasion to build sustainable healthcare for complex chronic conditions, long COVID and others in collaboration. And also, please don't forget prevention of infection, as it remains the utmost important thing to reduce the burden of long COVID. And thank you. And I'll just catch my breath.
Thank you so much, Dr. Anna Drew. And yeah, it's hard. It's very emotional to go through this journey. And thank you for sharing all your advocacy, your passion, your research with us. And we have tons of questions again, and they could be in French and English. So at the end of the next presentation, we will be reading some of them. Now I will pass to introduce Dr. Thao Nguyen, and she's a cardiologist. She sees a lot of patients with long COVID, and her talk, Mending the Broken Heart. So Thao, are you there? Could you please turn on your camera?
Yes, I am. Okay, so thank you for the invitation. Has been incredible hour of journey with the long COVID, and also an incredible year of caring of patients with cardiovascular disease following long COVID. So my talk is named Mending the Broken Heart, and this is what I have been trying over the last year. So over the next 10 minutes, I would like to describe you what we have done. The impact Quebec COVID-19 or IQ-19 was an international investigator initiated. Our group of collaborators came up with the design, and in May 2020, 2 months after the pandemic started, Pfizer launched an international competition. We won one of the 10 grants that were given by Pfizer Inc. So this is my disclosure of conflict. Saying this, Pfizer was independent of data analysis and also of data interpretation. The project belongs intellectually to the investigators and their patients. So finally, after 1 year, we have initiated in June 2021, there is a research project to evaluate long-term cardiovascular outcome following COVID-19 infection. And due to a large burden of unmet need of participants who were distressed, who did not know where to call, where to go, I have undertaken a program of care and have met at least half of the participants, either virtually or physically. And I would like to tell you their story. So far, since a year, we are all close to 250 patients, McGill Health Center and the University of Sherbrooke in collaboration with Montreal Research Institute. Our criteria for enrollment were at least one current symptom, shortness of breath, palpitation, chest pain, dizziness, and at least one confirmation of COVID-19, PCR, rapid testing, or the presence of antibody prior to vaccination.
It's
Yeah,
not
yeah,
sharing.
yeah. Excuse
Sorry, am I sharing?
me, you're not sharing slides.
Oh, I'm sorry. Okay,
Yeah,
let me
sorry.
just go back. Okay, sorry about that. Okay.
Now we can see it. Perfect. Thank you. Now you are muted.
Okay, sorry.
Yeah,
After
perfect.
2 years in the pandemic, I still have the logistic problem. We are good. Sorry about that.
All good.
Yeah, okay. So amending the broken heart, and I am cardiologist researcher at New York at the McGill Health University. And the impact COVID-19 was investigator initiated and won one of the grant of Pfizer. And since a year, it has become a program of care due to the large burden of unmet need of participants. We have enrolled close to 250 patients, mainly at McGill Center and some at the University of Sherbrooke in collaboration with Montreal Research Institute. To be able to enroll, patients have to have at least one current symptom, shortness of breath, palpitation, chest pain, or dizziness, and has to at least one confirmation of COVID-19 by PCR, rapid test, or antibody positive prior to vaccination. The project consists of a baseline and 1 year of biochemical inflammation markers, evaluation of frailty, quality of life, and nutrition. They will all have baseline and 1 year echocardiogram and a chest X-ray. And most of them will undergo a baseline cardiac MRI if clinically indicated. And because they all have heart disease symptoms, they literally 99% of them undergo cardiac MRI. These are the preliminary results on the first 100 patients. And I do not want you to focus on the exact number, but just on the key message. The majority are women, 80%, and 55% are healthcare and educational workers. The median age is 52, so fairly young, and 85% were more than 1 year following their first infection. 97% were non-hospitalized, so meaning the initial infection was very mild. All have fatigue, and 90% of them still had brain fog at the time of their first visit. So in a sense is that the patient, although their symptoms are non-specific, and I'm often asked by my colleague, how do you know long COVID? There are two questions that I ask is, do you have fatigue or do you still have brain fog? If you still answer yes to both, it would be much more likely that you will have long COVID that are associated with your cardiovascular symptoms. And a quarter of them will have inappropriate fast heart rate that can be either POT or paroxysmal, non-orthostatic. They can do nothing, they can be lying in bed and their heart start to race in the middle of the night. And the MRI still show in almost close to half of them active heart inflammation or swelling. And we're talking like 2 years after the first infection. And 30% of them will have a heart scar on the MRI with some fibrosis. The good news is that except 2 patients, One of the patient had prior heart disease, but so 99% have normal heart function. So although they are quite symptomatic, the good news is the heart function is almost always normal, despite the active inflammation. And the worst case in the healthcare workers, especially the patient attendant, and again, this is my hypothesis, maybe this was due to the heavy viral load, and this is mainly during the first wave of the 2000, prior to the infection, prior to the vaccination. Many got reinfected, some even had 3 infections. I will not, the mental stress is huge, and Kariana and Dr. Berra have mentioned, is we're talking super fit people. There is one patient who were a triathlon Ironman. There were many international level athletes who now have to use wheelchair to get around. Quality of life is dismal, and some of them tell me, I wish I can just walk 5 minutes with my kid. Broken union is extremely distressing to see the mental stress. So what's my wish list after a year working for this patient is raising awareness that healthcare providers and public policy makers should be aware of this syndrome. It's not psychosomatic, it is real disease, and they need help. They need financial support, they need emotional support, they need physical support. We all should work for a cure for the long COVID. And their multidisciplinary clinic are starting, especially rehab, because not everybody can do rehab for the long COVID. They need to know how to pace the patient. And one other item that I would like to stress on is the National Centers of Excellence. This is people who have worked with long COVID and they know what they're doing. Beyond the multidisciplinary clinic that are being started across Canada, there are a lot of people out there who do not know yet how to care for those patients. So we should recognize the expertise and we should transfer the expertise. I have patients who come to see me 12 hours from Montreal, like they live 12 hours. And they literally have nobody to turn to and nobody to understand. And they shouldn't do that. They should be able to access to care nearby their home. So as before the conclusion, I would just like to share you, this is the picture of the Northern Quebec, the big, with a beautiful sunset. And this is to illustrate what I need to tell you. So cardiovascular care for the long COVID is in 3 words, TPC. You need the time. You're not going to rush a long COVID in and out of your clinic. You will have to prepare twice the time that you need to see a patient normally. You need to be patient. They will tell you many symptoms that they have, but don't cut them off. And compassion, empathy, and respect, they are the distress. They need to be able to ventilate and need to be able to sometimes it's just listening to them will make them feel better. And what's this rainbow? My journey and my patient is a journey toward unknown destination. A lot of hidden waves and stumbling blocks. One step forward, many steps backward. And the most distressful thing that I have to say, I have to look them into the eyes and I say, I do not know when will your symptoms end. All I can say is that hopefully there will be a rainbow at the end of this road. I will mention all my team and my collaborators. Without them, this project would not have rainbow at the end of this journey for my patient. And I hope the policymakers, the media who's listening, help us to get our patient back to their very productive life and the society becomes a better world. Many thanks for your attention.
Thank you so much, Tao, for such a important presentation. Yes, you're right. Compassion, it's important. It's an unmet need in healthcare, and we need to all work towards a compassionate healthcare. So we have a few questions now before, and I will start reading some. Tao, are you still sharing your screen? And maybe stop sharing? Yeah. Thank you. Okay, so we have questions for Dr. Iwasaki. Given the main hypothesis, are there any approved therapeutics that might work that can be trailed off label?
So I want to make sure that whatever I say is not taken as a medical advice by anybody. So that's one disclaimer I should have made earlier. But the reason I think it's very important that we understand the driver of disease is because let's say if somebody is suffering from long COVID because of viral reservoir, there are some specific drugs that can treat that. For example, the Paxlovid, monoclonal antibodies, and potentially even vaccination. So, the type of medicine that we would use to treat a persistent reservoir differ very much from, let's say, if a person had autoantibody against specific antigens in the body, in which case we want to provide immunosuppressive drugs. Or to specifically interfere with the autoantibodies. So that is why we need to understand the drivers of disease, because ultimately we need to know what to treat and what medicine and what the schedules are, and in a randomized clinical trial that has a placebo arm in order to really understand the effectiveness of a particular treatment. So I hope I didn't mislead anyone into thinking that we should all be starting to try something just sort of based on some of these basic hypotheses.
Thank you. There is, in addition, there is another question. You might know the answer. Has plasmapheresis or apheresis has been tried for long COVID patients, and what are the results?
Yes, there are some apheresis being tried in long COVID patients. This is sort of based on the international collaboration that Dr. Pretorius and others are doing with microclots. And so they are seeing that, of course, after apheresis, the microclots are mostly removed from their circulation, and that patients have a transient improvement in their symptom. However, the clots come back pretty quickly and they resume with their symptoms. So I don't know if I would say that that is a kind of a treatment that people should be getting, with the understanding that it's not a permanent solution. And so, but I do know that people are trying these types of treatments to see if there's any improvement there.
Thank you. And another question is there any studies that involve vaccination of vaccines in long COVID? And if you can quickly summarize those results.
Absolutely. So that's sort of the reason why I started this new cohort that I was, one of the cohorts that I described is actually a vaccine trial. A vaccine trial meaning that people who have long COVID, who haven't been vaccinated yet, but are willing to donate their blood and saliva, have done so. And then we are following what happens to their immune responses after the vaccination, and to compare their symptoms to vaccine-induced immune changes. And in many participants, we see that they report improvement after the vaccination. And in those people, we also see a subsequent change in the immune profile that bring them closer to sort of a healthy person level of various factors. But it's not by any means a cure for them. Some people experience transient improvement, while others have much longer improvement. So it's a very heterogeneous outcome, and others feel worse from vaccination. So we need to be, we're not using vaccine as a therapy, but as a tool to try to understand how their immune responses differ in those people who develop improvement in their symptom versus those who do not.
Thank you, Kiko. There are many more questions, but I'm gonna send a different ones now for the panel. Yeah, if you can please, maybe if you have a minute, answer some more specific questions in the chat, that would be great. Thank you so much. Yeah, there is another question. Exercise has been my sanity. Is there hope for regaining better than baseline function and endurance? And what are the factors? Any of the panelists, maybe Tao or Annie, could answer this?
Go ahead, Anne.
Oh, well, actually, it really varies. It's not all patients that have post-exertional malaise. It's probably at least about half, but we don't have very good prevalence studies yet because groups are so different, as I said, in different studies. And unfortunately, we have no clue, as for PEM being neglected for so long, how to try and recover, and how to, when eventually in some lucky ones, PEM do stop to happen, but we have no idea what are the signs and the thresholds that we have to progressively go back to exercise, and if possible. This is an area where we really need to have good studies. So I would really vouch for every study on long COVID to take PEM into account, record, and see what happens with them, because so many studies still don't. And that's a question we really have to answer.
Thank you. Related question is, so one of the problems with CLH is the exertion, and one of your doctors point out there is not enough oxygen getting in the cells. What can I do to get more oxygen in my cells? Tao, maybe for you?
Sorry, can you repeat the question? I'm not sure I understand it well.
So they say that one of the doctors point out there is not enough oxygen getting into the cells. And what can I do to get more oxygen into the cells?
It is actually, there is a theory, there's a hypothesis. That's not the oxygen that you don't have, but mainly is that is the problem of the cell to use the oxygen. There are some studies that mention that. So it's unclear. The answer is still cell can metabolize the oxygen. And science does not have the answer yet. So sorry.
If I might add, from a patient perspective, one of the things that you can do is stop, rest, and pace. So that's one of the most important things we've learned from the ME community, is that when we are overdoing it, when we have post-exertional malaise, when we hit our anaerobic threshold and we get that feeling of not having oxygen in our muscles, that's a sign that we are probably heading towards post-exertional malaise. We've overspent our energy budget. And that means we need to stop. We need to rest, and we need to pace. And pacing means cutting our activity by at least half, and resting ourselves physically, cognitively, emotionally, and staying within our energy budget. And that's one of the ways to avoid post-exertional malaise and to reduce its frequency and intensity, and to avoid relapses and to feel better, generally get a better baseline. We're still ill, but by pacing, I'm able to reach a better baseline and not always feel like my muscles are starving for oxygen. So from a patient perspective, I hope that helps.
Thank you, Carrie. And a related question, and there is a curiosity says here. So apparently many patients walking through the door and the ER with extreme desaturation, and so gasping for breath. So the suggestion is maybe uncoupling of normal low oxygen response with behavior. Is it possible this is part of what leads to damage with long-term consequences in the long hauler syndrome? Do you think is the lack of oxygen that is damaging some of the cells and then long-term they can't recover?
Maybe I can also add to that. So in our experience, it's not that people aren't getting enough oxygen, but the cells aren't able to utilize that oxygen properly because of the mitochondrial dysfunction. So I think the problem is in utilization of that oxygen by the cells in our body. And how do we restore mitochondrial function in cells? That's the sort of a next goal of try to understand how to restore some of these important functions. Mitochondria is really the energy center in our cells, and without that, having low energy literally means that we cannot utilize that oxygen properly to generate the energy. So I would just add that insight there.
Thank you so much. We have many questions, and I know we are running out of time. However, we will keep your questions, and we will have this conversation all day. And please turn up your social media. And before going into the final remarks, I wanna say thank you to our partners. Science Up First was crucial in this. Special thank you to Prashana for helping. Hey, Dr. Sam, thank you so much. We wouldn't be doing this without the support of the team of COVID-19 resources. Fatima, Adrian, Grace, Owen, Tara, Hira, everybody, thank you so much. And we have a survey. Grace is a student, is a master's student and turning into a PhD student that is trying to understand how these public events with scientists, with patients are helping trust in science. So if you could please help her fill up some of the surveys, that would be really appreciated. With that, I would like to introduce Senator Stan Kutcher. He is a psychiatrist, and he is instrumental in generating this Long-COVID Awareness Day here in Canada. Dr. Senator Kutcher, welcome. Please, we want to hear your final remarks. If you have any way that we can reach our health providers, the government, and bringing more awareness to long COVID, that would be nice to hear from you. So please turn on your camera and your microphone.
All right, and thank you very much, Dr. Valdez, and thank you everyone who got together to create this long COVID Awareness Day, and for your kind invitation to participate. And you're right, I'm very concerned about this. I raised this already in the Senate as a major concern, and I am willing to work with you and the patient community, the public, and the health providers and researchers community to push this agenda more vigorously in Canada for sure, but also in collaboration with colleagues in the United States. So Dr. Iwasaki, if I can hear from you at some other time, there are some ideas for doing that as well. I just want to thank all the panelists for their incredible, just outstanding presentations and for all their hard work as they help us learn more about long COVID and the raising of awareness about these complex and incredibly challenging issues. I'd also like to thank all the organizers. It's essential that the Canadian public, healthcare systems, policymakers are aware of the importance of long-term COVID and its potential impacts on health and wealth of every Canadian. But let's be clear, while awareness is important, it is, and is an essential first step, it is clearly not enough. We must move quickly beyond awareness to meaningfully and robustly address the key issues. And there are three things that I would like to put on the table that I think we have to move forward on very, very fast. The first is rapid creation and dissemination of robust, best available science-based knowledge. The second is public preparedness and a proactive communication strategy. And the third is health system readiness and improved disability support. So I'll take each of those in turn. On the first one, the current budget cycle in Canada has identified about $20 million to support research into long COVID. While this is a welcome start, it's a small fraction of what is actually needed. This funding allocation is also directed to research multiple aspects of long COVID, so you can guess how this might be distributed. The worry is that a little bit will be given to everyone who raised their voice with the potential outcome that much will not be accomplished. I call this a peanut butter spread on bread approach. And it's in my opinion, we need two things to happen simultaneously. First, we need a national strategic plan for research into long COVID, including its treatments. And second, funding of sufficient quantity and duration to enable that plan to be delivered. Strategic plan followed by funding. That way we can try to improve our chances of getting the biggest return on our investments. I personally don't know if such a direction has been set yet by the federal government, but even if there has been some movement on this, it is essential that provincial and territorial governments are also involved right from the get-go. Many provincial governments in Canada have substantial research funding capacity, and this must be used to address this need. It should also be coordinated with federal government commitments. We know only too well what happens when there is a lack of consensus, collaboration, and co-funding for health challenges in Canada. Let's not recreate the problems our pandemic response created and that we have witnessed, sadly, over the last 2 years. Let's not recreate that with our long-term COVID response. The second issue is public preparedness and clear proactive communication. We have all lived through the chaotic and problematic response to the arrival of COVID in Canada. I will not detail the litany of problems that arose from lack of pandemic preparation, nor from the challenges that arose because of communication that did not proactively address the emergence of conspiracy-driven anti-public health activities and the lack of consistency nationally in public health response measures across our provinces and territories. Sadly, this continues to be the case. Simply put, we can't continue with this kind of hodgepodge approach to long COVID. It's the responsibility of federal, provincial, and territorial governments to work collaboratively to effectively address long COVID. This is an issue of health and healthcare. It's not a political football game. And I have some ideas how we may try to move this collaboration forward. And hopefully Dr. Valdez and others will be in touch with me after this conversation. Another issue that I want to raise that came up during the pandemic is that tsunami of disinformation and actually malinformation that the pandemic unleashed. We expect to have that continue and even be amplified more during long COVID. Many aspects that we have already seen will arise again, particularly false news around the effectiveness of various different kinds of products, their sale and their distribution and dissemination of unproven alternative treatments, unproven alternative hypotheses, and we must get out in front of this. Science at First has done a great job on debunking and addressing much of this disinformation during the pandemic. One thing I think Science at First and the Moriarty Lab and others have learned is that we have to get out in front of this stuff, that we have to get the entire science community involved. So those of you who are on this webinar, whether you're a patient, a member of the science community, an interested bystander, a family member, a policymaker, we want you to get involved. So please reach out to organizations such as Science Up First to see how you can help, how you can become part of the solution in this issue. And then the final thing I want to just briefly touch on is health system readiness and disability support. The Public Health Ontario Rapid Review of Long COVID published in April of this year says, and I'm going to quote from it, PACS is a condition experienced by a substantial number of individuals with previous SARS-CoV-2 infection. Care for patients with PACS will likely place added stresses on healthcare and social support systems, including increased emergency department visits, outpatient care, inpatient care, and rehabilitation involving multidisciplinary teams. Simply put, it is predicted that long-term COVID will lead to substantive and sustained impact on our healthcare system. Let's remember that this is a system that can be currently characterized as now running on empty. Our healthcare providers have carried the burden and the brunt of this pandemic. Rates of burnout and provider distress are at unprecedented levels. Our health provision infrastructures have been tested and have been found wanting. Can we expect this broken system to now rally effectively and cost effectively to address the needs of Canadians suffering with long COVID? If the answer is no or not likely, we can only expect more of the same. So we have to, at this time, start moving very quickly to make the changes in our healthcare system and enhance the capacity and numbers of healthcare providers, because long COVID will put an even additional strain on the system and on the people who work in it. So I would strongly encourage, again, that the levels of government who share responsibility for how healthcare is delivered across Canada begin to act now. And that this action must ensure that those groups of Canadians who have been most negatively impacted by the pandemic are not once again left behind. And additionally, as Ms. McGuinn so clearly put, she pointed out clearly to us that long COVID may, in significant numbers of people, lead to long-term disabilities. Given this reality, we will need to strengthen disability supports in this country. There are many tools that can be used to do this federally, provincially, and territorially. But policymakers must now begin to prepare for this, not sometime in the future, but now. So we do have the means to do this work. It will be challenging, but from the policy level, we need to move now. One thing that I'm going to ask you to do is to think how you can work together with policymakers, such as myself, to ensure that these issues get right front and center on the agenda, because these are substantive concerns. They're going to have major impacts in not just the health, but the wealth of our society. And they're going to impact not just the people who have long COVID, but their families, their friends, and their communities. So once again, I just want to thank you so much for beginning this national conversation. This is the start of the conversation, not the end of the conversation. And this is a conversation that must lead to action. So thanks again to all.
Yeah, with this work, Thank you, merci, gracias. Thank you to everybody that participated, but we have the entire day today to hear the voices of the patients, policymakers, clinicians, scientists, what do we need to start this conversation. Thank you, everybody. And with this, I think we are ready to sign off. Is that okay? Adrian, any?
Nope, I think we're good. Thank you so much, everyone, for joining. It's wonderful.
Thank you, Senator. Thank you, Kiko. Thank you, Carrie, Tao, and thank you for your time. Thank you for being here.